Thank you very much, Richard. I hope everybody can see my screen now and the presentation. As Richard said, we are very happy to present the achievements we made within Annex 71. We started some 6 years ago with a lot of ambition. We probably were not able to reach all the goals we have set, but anyway, we're happy to show the achievements, what we have done, and I think we are very proud of what we did so far. So let's shortly introduce the project itself. So IEA EBC Annex 71 on building energy performance assessment based on in-situ measurement. It's a very international project. We have been working with 11 countries, and for the different countries, we had most of the time several institutes participating within the project. So it was a rather large project. As you can see, all of the countries were European countries, but at least it shows that there's from within Europe a very huge interest in building performance assessment based on in-situ measurements. We started with a kickoff meeting in 2016 in October in Leuven in Belgium, and then we had every year 2 meetings. April 2017 we went to Loughborough, UK, then Chambéry, France, the next year to Brussels in Belgium, and in autumn to Innsbruck in Austria. 2019 we went to Bilbao in Spain in spring, and in Rosenheim in autumn again. And then April 2020, we were supposed to go to Trondheim. Unfortunately, from then we had to do all our meetings online, which is not easy for such a project because typically these are really working meetings. So we work together with common exercises and try to achieve that way new results. But we managed to finalize our project that way and even to write the reports and have the final discussions, all of that online. Let me take a look at the main objective. I would like to start with what we have put forward as our main objective at the start of the project, and we defined at that moment as to support the development of replicable methodologies embedded in a statistical and building physical framework to characterize and assess the actual energy performance of buildings starting from onboard monitored data of in-use buildings. So mouthful, and what we actually were aiming at is, can we characterize, assess actual energy performance, the real energy performance of buildings as they are performing in use? And we would like to do that with just the monitored data, which is typically monitored while the buildings are in use. And we try to do that by using statistical methods which are embedded in a building physical framework. We use our building physical knowledge and combine it with statistical methods. The rationale behind the project was that today there's hardly any operational rating and there's little measurement-based optimization of buildings. And at the same time, we saw that we have Internet of Things, we share a lot of data, we have more and more home automation systems which collect data on temperature, indoor temperature, etc. And we have in a lot of buildings nowadays smart meters installed which collect energy consumption, etc. So the question was to what extent can we use this onboard monitored data to assess and predict the energy performance of our buildings. A lot of focus went to quantifying the thermal performance of the building fabric, the so-called heat transfer coefficient or heat loss coefficient of a building. Today, that's a very theoretical approach. Nowadays, we typically assess the thermal performance of the building fabric based on simplified calculations as a SAP or EPB or EPC calculations. So actually what we do is we rate our buildings based on the building plans and the specifications, and we do not take into account the real building delivery. So we don't take into account changes that have been made on the building site, workmanship that plays a role, moisture, etc. So the question is, to what extent does this energy labeling based on the building plans and specifications corresponds to the actual energy performance? And what we see quite often is that the actual quality or the actual performance often turns out to be much worse than expected. And these are really missed opportunities to optimize our energy efficiency. If we want to come to a climate neutral environment, we need a very energy efficient buildings, not based on building plans, but in reality. To characterize or to assess the as-built thermal quality, we have different options. We can assess the performance of a specific building component, doing that by U-value or R-value tests. So we install thermocouples and a heat flow meter on the building component, and then we can characterize the as-built thermal quality of this building component. Or we can go to specific heating tests, like co-heating tests, where we try to assess the global overall thermal performance of the whole building. Or we can go to on-board tests. This is much more complicated. What we try to do there is try to determine the thermal performance of the whole building envelope, but while the building is in use. So we have the heating system of the building itself, and we have users in the building who are all the time disturbing the measurements we are trying to perform. The first two have been focus of IEA EBC Annex 58 project. So in this Annex 58 project, we have been looking at statistical methods and then mainly looking at dynamic methods, which could speed up the determination of, for instance, R value or a co-heating test, the overall global thermal performance of the building fabric. Within Annex 71, we made a step towards onboard tests. So we go to real in-use buildings and we try to determine the performance of the building envelope while the building is in use. So estimate the as-built thermal performance of the building fabric based on measured data during normal operating conditions. And that's rather complicated. So what we are looking for is actually so-called heat transfer coefficient or heat loss coefficient. It's a measure of the thermal performance of the building fabric, taking into account heat transfer through conduction via the building fabric, as well as effects of air infiltration, etc. But even if we would simplify the building as one simple building zone, which is not reality, which is already an important simplification, we end up with this heat balance equation that you see on the top. And somewhere in this heat balance equation, this HTC is embedded. But you see a lot of terms, and all of these terms are varying in time and are very hard to assess. So it's rather complicated and much more complicated than in a co-heating test. This topic has been part of what we call subtask 3 within the project. It's only one of the aspects. So if we look at the overall structure, this subtask 3 dealt with what we called physical parameter identification. So there we would like to try to characterize, in this case, the heat transfer coefficient of the building envelope, a physical parameter of the building. And at the same time, for instance, we have also been looking at the solar aperture of the building envelope. Subtask 2, we called it building behavior identification, started from a similar kind of data, but instead of trying to determine the physical parameter of the building, we try to determine the building behavior. So try to predict the response of the building to different conditions. And these models can then be used, for instance, in model predictive control, fault detection, etc. In subtask 1 of the project, we have been looking at the input data. What kind of input data is at hand? How far is, for instance, smart meters have been enrolled within Europe? What kind of weather data can we typically use, etc. And the subtask 4 has been looking mainly from the viewpoint of our stakeholders. What do they actually expect as a kind of outcome? And what are they, for instance, willing to pay to get this outcome? What kind of reliability do we want to have? And then another important element of the Annex 71 was the link with building energy simulation models. Already in Annex 58, we did a full-scale validation exercise for BESS models. That was still limited. It was full-scale, but still limited. Within Annex 71, a new building energy simulation validation exercise was performed, again on a full-scale building, now multi-zone, and as well with the building in use, means that we use the heating system of the building itself and that we made use of artificial uses. So a step forward in BESS validation possibilities. And then finally, we have what we call the Network of Excellence. We have been working together with Dynasty. Dynasty is a subdivision of INIVE, and Dynasty has been taking care of dissemination of the results of Annex 71, as well as taking care of organizing summer schools, etc., to instruct, to educate people who are willing to do this kind of full-scale experiments and statistical methods. We are now at the end of the project, and a lot of people have been very busy beginning of this year to finalize the reports. And you see them here. So we have one report combining subtask 1 and subtask 4. So combining the input parameters and the expectation of our stakeholders. We call it Challenges and General Framework of Building Energy Performance Assessment. Then we have a report on building behavior identification, where you can find results on how to apply these methods for model predictive control fault detection. A report on the physical parameter identification, which mainly has been looking at the determination of the heat transfer coefficient, starting from the equation I just showed you, and where a lot of case studies have been included. And then we have the last report on the best validation exercise, where you can find a description of the exercise, description of the full-scale experiment that has been performed, as well as the result of the blind validation that has been done. The reports can be downloaded from the Annex 71 website or from the Dynasty website, and they will soon also be available at the official website of the IEA. We will put those links in the chat so you can find the final reports there. That brings me to the agenda of today. As Richard said, we try to keep it rather concise. Online meetings, it's always a burden if they took several hours or even days. So we will present today the final outcomes of our meetings, of our Annex 71 project. We will start with introduction, a keynote by Professor Swan, who leads the Applied Building and Energy Research Group at the University of Salford. And then we will present the outcomes of the different subtasks, but after each subtask, we have a talk from somebody outside of the Annex project, but very, very much related to what we have been doing. So hope this way we get a nice interaction between what we have done with Annex 71 and the relevance for practice. As said, the Q&A section will be gathered at the end of the meeting. And it's a limited time, so for questions, we will gather them in the chat. But as Richard said, please, if you have specific questions, mail them to Richard, and then we will try to answer them afterwards so that we can keep it to the point today.